And I am a little concerned about generative AI. And it's like, there's this idea that, well, we'll now be able to generate code for everything, right? And even generate documentation and generate expertise effectively out of these things. The problem is that they're not right yet. And they're not right a lot of the times. And oftentimes they're wrong in ways that are really dangerous in terms of like the plant floor. So
we are the Keyboard Samurai, podcast about the business of cyber and tech, here to help you or your business improve. Here's your host, Wil Klusovsky. Let's hack into it now.
Hey, everybody. Welcome back. Excited today to be bringing Bryan on. We had our little intro chat, and he's going to know some stuff I've never heard of. So we're going to have some really good questions, I think. Bryan, why don't you give everybody the 30 seconds of who you are and why we care?
Yeah, for sure. So as you mentioned, Bryan DeBois, Director of Industrial AI for a company called RoviSys. So we are a industrial system integrator, sometimes called an OT system integrator or operational technology system integrator. And we are a system integrator in terms of our focus is to, I always say, our goal is to build a solution that solves a problem for the customer, regardless of how many systems it has to touch, right? So, and especially on the plant floor, which is kind of our world, there's some very old equipment. There's obviously a lot of efforts to modernize and bring in things like cloud technologies and Docker containers and things like that. And so bridging that gap and staying focused on building a holistic solution that solves a problem for the customer, that is our focus as an SI.
Awesome. Well, okay, so I'm going to ask, because I've chatted with a couple of other SIs lately. Are you, and I mean you, Bryan, are you one of the people who's like, okay, we need this assembly line. It's going to be made up of these Rockwell devices, these Siemens devices. Like, are you structuring all that and building it all out? Or are you doing one part or like holistic? Like where?
Yeah. So it's really interesting. Like I knew nothing about it. I've been with RoviSys my whole professional career, so 26 years. And I had a computer science degree coming out of the University of Akron. So I really knew nothing about manufacturing when I started. So it's been fascinating to learn this world. And one of the things that I found is there's actually a lot of like niche services in this space. So if someone came to us and said, I've got an empty building and I need to put in production lines, right? And I need to basically design the process, that's not us. Right. There are process engineers who do that kind of thing. We don't even really build the equipment per se, though that's a whole different niche thing in our industry called OEM or machine builders. But all of those people rely on a system integrator like us to actually make everything talk to each other, make everything work. So otherwise, you may have the equipment sitting there, but nobody would know what to do. Everyone would be standing around staring at each other. So we're the ones who actually come in, like you said, we're going to spec it with Rockwell, Siemens, whatever the customer wants. We're independent from that regard, and then actually make write all the PLC code. So for some of your listeners, that's the low-level code that these tiny computers called PLCs on the plant floor that control everything. These are the things that turn on valves and turn on conveyance and turn off like that. Those computers are, we write that code all the way up to, if you've ever seen the show How It's Made, those screens that people walk up to and they type on, those are called HMIs. Build and design and implement all those. And then we go even higher. There's big software systems in this world called MES, Manufacturing Execution Systems. We do the implementation of those. We do the industrial networking and the cybersecurity and locking down the plant floor. We integrate to the ERP systems, the big business systems and financial systems. We integrate to those. We don't work on those. That would be a difference between us and like an ITSI.
Right.
And then one other thing, and then the AI, right? Of course, so that's what I do then. So then that's the last piece of the puzzle is I do industrial AI for that space.
Right, the industrial AI. And for those, like, as you were saying that, it immediately clicked to me. And I'm like, oh, okay, I get it. You are, and I've worked for some IT systems integrators. For those listening who kind of didn't catch, right? You've got your Cisco, Fortinet, Palo Alto, whatever devices and your Microsoft suites and your SAP, and you're the one, I would be the one who comes in and put it all together, right? And in those worlds. So that's what you are. You're taking all that technology and operationalizing it.
That's right. And just a level lower, right? So
sure.
Primarily, I used to say within the plant walls. Now with cloud, that kind of blows that up. So, but that's kind of the idea. I've been asked before, is there like a bright line between what an OTSI and an ITSI does? And I'd say The only thing I've ever really come up with is that there is almost never financial information in any of the systems that we touch. So if there's financial information, that's going to be in ITSI, things like you said, like accounting systems and SAP and those types of things. On the plant floor, it's typically you're measuring things in gallons of stuff you produced or counting, number of widgets you produced, that type of thing. There's almost never dollars down there.
Right. Yeah. And as somebody who's done the selling and solutioning for the IT and the OT, usually that line is pretty clear between like, this is the IT, and it's sad how clear it is, because if I go in and talk to the enterprise side, there's a CISO, a CIO, a CTO, and there's ERP systems and enterprise risk management and all these people over here that are protecting email and everybody's payroll. But then you go to the shop floor and there's like a floor manager and like 7,000 workers, and like that's it.
Yeah. And I will say though, one of the things, and I know not everyone loves this term, but over the last 7 to 10 years, we've had this thing called IT/OT convergence.
Yeah.
And so that's where, from an IT perspective, IT is starting to take control of a lot of the systems on the plant floor. I don't fault them for that. I mean, when I started in my career 26 years ago, it was kind of the Wild West. Like if you needed two systems to talk to each other, someone ran out to Radio Shack and bought a hub or a switch and just plugged it in.
Yeah. And it's still air gapped. Sure.
Right. Well, and air gap was always the reason why that was secure. But even then, like it turned out there was a lot of double nicks and there was all kinds of bad practices happening. So I don't blame IT and again, so in 2010, with the release of Stuxnet, which was the first ever control system virus that we know of, that really opened up a lot of people's eyes. That was around the time, a couple of years later, we started our industrial networking group to focus on cybersecurity and locking down the plant floor. So that's kind of what IT brings. And then OT, of course, what they want from OT is they want the insights, they want the data, they want, the business wants all of that information that's coming from the plant floor, because that's their lifeblood.
Yeah. I know working, having, like I mentioned before, I built an OT security practice in the past, and the products were not born of security. They were born of asset management and visibility, because they want to know if that device isn't running, why isn't it running? Why aren't we making money? Right. So it's all very so that idea of it's all very foundational, and again, in the business process. So I would agree on IT. I don't want to say taking over, but getting involved.
Yeah, getting involved.
Yeah.
Yep.
But so you said two things in one sentence I wanna dig into, because I think it's funny. Not funny, haha, funny, interesting. You mentioned PLCs, right? And we know there's PLCs that have been out there probably since the 70s, 80s that are still into production, maybe older, like even, if I'm being honest. But you work in AI, right?
Yes.
So how is AI being applied to this ancient technology?
Yeah, I mean, it's a good question. And it's one of the fundamental questions that I get from my customers when I first come in and sit down with them, because that's what they want to understand is that they're like, everyone's like, sometimes it's kind of a badge of honor. They're like, oh, my stuff's 25 years old. So yeah, I get it. It's all old. So how can we do that? Well, so there are things that we can do. So when you think in terms of PLCs, what they really do, I had a systems engineer once describe it to me this way. He's like, think of a thermostat. So what these PLCs ultimately do is that you give it a set point. So I want the house at 70 degrees, right? And then that thermostat works and, controls all the different things, heat, cool, dampers, whatever, to get that, right? To keep it there. It's the same exact thing. Like if you want to boil a reactor and you want to get it to a certain temperature, then you're going to tell the PLC to hit that set point. Now, where do those set points come from? And this is the part that a lot of people don't realize about modern manufacturing. In a lot of cases, those set points are an operator setting those set points manually. It would be like someone standing at your thermostat and manually turning the temperature up and down. And really even less than that, really manually controlling the dampers and manually, that's really the level of automation that we have. And so like in a broader sense, when we talk about onshoring and bringing US manufacturing back, I am all on board with that. That sounds great to me. However, I've actually been in these plants and I know how far away we are from this utopia. And so what ends up happening is the final quality of the output of whatever product you're making becomes highly dependent on the skill of the operator. Well, why is that a problem? Because right now we are seeing a loss of expertise, a massive loss of expertise in US manufacturing. And so with that comes this need then to fill that gap. And so many of my customers are looking to AI to fill that gap. The PLC itself doesn't really care where the set points come from. So it doesn't matter if it's a really expert operator, a really smart operator that's got 20 plus years experience, and all of those are disappearing, or if it's an AI program that knows the process really well and sends those set points down, doesn't make any difference to the underlying hardware. It could be 20-year-old hardware. It's going to respond in the same way. So that so process optimization, which is what we call that, is a key area. It's not the only area. We also look at production scheduling, and we look at energy consumption and reducing that and things like that. But that is one of the key areas that our customers are interested in.
Okay, so, and that makes total sense to me, right? You've got, again, and I think we haven't probably been, we've left the days of the people standing on the assembly line a long time ago and making a lot of those calls. But I'm curious now so how are those AIs trained? Do you have to train specific? I'll use an example. I have a friend of mine, a buddy of mine, who created a very good AI tool for GRC. He trained it on, his experience, all the other stuff. And basically he has a pool of PhD level GRC consultants that you can access. Mm-hmm. So I would assume you've done something similar where you're like, okay, I'm working in this type of plant, or it's pressure relief valves, or it's whatever it is. Like, how are you training those devices, or the AI, I should say?
So it's actually difficult to build some kind of master, and we don't really use honestly, we don't use a ton of foundational models and generative AI.
Yeah, you wouldn't.
It's not really that world. This is older AI technology that predated the launch of ChatGPT in 2022. A lot of people think AI didn't exist before then. It certainly did.
1940 something, I think, is when it's technically.
Right, exactly. Yeah, I studied it when I was in school in the 90s, So we use this technology. So what we do though, so how do you train it? So you take the data from the plant floor, and that's where, so in our world, we have, for your listeners, we have large, what are called time series databases. They capture all the process data that's on the plant floor. We also, I mentioned MES systems. We've got transactional systems, SQL databases. So we have all these sources of data on the plant floor. And now this is where some of the modern technology comes in. There's actually a lot of options now to be able to bring all that data together. We typically use the cloud for this because we're talking about big data. Bring it together, correlate it, cleanse it, because the data from the plant floor is oftentimes very dirty, and very siloed. So we have to bring it all together. But once we have that, now we have a history of a historical record of how the system has responded given different inputs and things like that. What are the outputs when, and it's just inputs and outputs. And so with that, then we can train these models to pick better outputs, pick better set points. And there are some traditional ML approaches that we can use. And then there's some more modern, it's 10 years old now, but deep reinforcement learning, which came out of DeepMind about a decade ago. RoviSys has been kind of pioneers in leveraging deep reinforcement learning in building really, really capable models. We call them autonomous AI because they are very, very good, almost human level at running those parts of the process.
So would you say deep resource modeling?
Deep reinforcement learning.
Deep reinforcement. Okay, so how does that work? How is that different than training in how an LLM learns?
So with an LLM, obviously you've got a big corpus of text typically, right? And then you're going to send it in, and it's going to take a long time, and it's going to boil the ocean, but eventually the foundational model will come out of that. It's different in the sense that DRL learns like a human does. So it actually has to have a simulated environment to play in. So this is the most advanced AI that we do. We actually first have to build a simulation of part of the process, and then we can hook a DRL agent up to it and actually train then on that simulation. It's the same way. So DRL came out of DeepMind, which, if some of your listeners remember, it was 2016, and they released AlphaGo, which played the game of Go, and it beat all of our Go grandmasters, and AlphaZero, which beat all of our chess grandmasters, and AlphaStar, which beat all of our StarCraft masters. And so that technology, that innovation didn't go away. We haven't heard as much about it in the news and things like that, but it's actually now penetrated into finance and all kinds of different industries, including the industrial manufacturing space. And so we actually are able to hook it up to this simulation. Now, one of the things about that is that some people get a little nervous about that because they go, well, building a simulator takes a long time. Like, we don't really have first principles simulators on the plant floor. And it's like, that's fine. Nobody does, right? Like, we get that. What we're doing is we're building more of a surrogate sim. It's a what we call a data-driven model. So we leverage that data from those historians, those process historians, and with that, we can then build a lightweight sim. It only has to be good enough. DRL is extremely good at generalizing, even in the face of noise, in the face of partial data. It's very, very good. So we don't have to give it a perfect sim. We can give it a good enough sim, and then we're able to validate that model, and then we test it, of course, very heavily before we ever let it near the equipment. And then keep in mind too, it's always being deployed in decision support mode first. It's showing the set point changes to an operator, and a human who's in the loop, a human is making those changes to the control system. It's not a situation that this is direct control on the device.
So those sims, is that like a digital twin?
It is a digital twin, okay. Yes. Yeah, and I think that there's more to be said about digital twin. Like, there's a lot of hype around digital twin, and people don't really know what it means. But if it means anything,
2020 to 22ish, like it was really big. Yeah.
If it means anything, it should mean lightweight simulations of the real world. And I will say, to kind of tip our hand a little bit, there's some stuff coming around using the transformer architecture, which is the underlying architecture that made LLMs possible, using that for things other than text. And so there's some things coming around physical AI and building these physics-based models instead of text-based models, physics-based models of the world. And I'm excited. It's early days, but I'm excited about the possibility of maybe leveraging those to do some lightweight digital twins in our space.
Like so you'd have like OT in the metaverse, so to speak.
Yeah, in a way, and in the same way that LLMs use probability to effectively make it possible to do what they do, it would use probability. So it's not going to be a perfect sim, but honestly, I don't need a perfect sim. I need a fast sim, to be real honest, that's good enough, that's close enough.
Right, to run your model and run the tests. And as you said, there's still that human in the loop. And we talked, and you mentioned the fact that the 20 years of experience on the shop floor, that's going away. We're seeing the same thing in cybersecurity, where it's great that we're able to kind of automate out sort of the low level grunt work, but that's also where everybody learns their foundations.
Right.
So I'm going to ask you similarly, within the manufacturing space and within that world, what does that future look like when you now need somebody who has to check on the AI and make the decision call and be like, yeah, no, that's good enough. I think that makes sense, but they have no experience, or where do they get that experience, or how does that even happen now? Or in the future?
You're asking the right question. I don't have the answers. Like, I am very concerned about that. So my background software, when I started at RoviSys, I was writing code for these manufacturing companies and wrote a lot of software in my day. And I am a little concerned about generative AI. And it's like, there's this idea that, well, we'll now be able to generate code for everything, right? And even generate documentation and generate expertise effectively out of these things. The problem is that they're not right yet. And they're not right a lot of the times. And oftentimes they're wrong in ways that are really dangerous in terms of like the plant floor. So, and cybersecurity. So like, I don't know what happens. Right now we have experts that can double check their work, but I'm in the same way you are. I'm concerned about that. I don't know how you develop that expertise then, if the thing is doing it all for you, and then we're just relying on experts to go clean it up later. I think if you asked, an generative AI evangelist, they'd probably say, well, that's just for now. It's going to get better and better. I guess we won't need the experts to double check it. I don't know. I'm not convinced. Call me a skeptic. I'm not convinced on this whole generative AI train. I use it every day. It's great to generate a document or something like that. But yeah, I'm not bought in 100% yet.
Yeah, I'm there with you. I use it every day. It answers my questions the way I want it, and I can tell it the level of depth I want. I can learn much faster. But I'm there with you too. If we get, I kind of believe if we get to the point where the AI gets, and I know it's going to get smarter, but that just puts us into idiocracy mode where people are just pushing buttons with pictures on it. And we've all seen that movie and how that ends.
Yeah. So, yeah, makes me nervous.
Well, Bryan, this has been great, man. Where can everybody find you on the interwebs should they want to?
Yeah, have them look me up on LinkedIn. I'm sure you're going to put it down in the description box. It's Bryan DeBois on LinkedIn, and then they can always check out my company's website, which is RoviSys, ROV as in Victor, ISYS.com. If you put /AI, you'll get to the AI section of our website. But yeah, happy to connect with anyone and talk with anyone about all this stuff.
Yeah, this has been great, man. I really appreciate your time, bud.
Yeah, thanks.
Thanks.
Thanks for listening. Be sure to like and subscribe. Follow Wil and the podcast on LinkedIn /WilKlu. Visit WilKlu.me for information on services he offers to help your cyber or tech business grow. Until next time, Synaculator.